This is Face Battle, a grotesquely fun shared AR experience. Welcome to the Replicality. In this space, somewhere between reality and virtuality, tiny creatures called Replets roam the world. And they're up for a fight. Capture your face to summon a cohort resembling you and battle your contender with the worst weapon imaginable, metallic red orbs. Will you be the one to emerge as winner, or will your cohort leave you stranded alone? Grab your A&E equipped iPhone or iPad to play. Face Battle is previewing now in alpha for ETH VR1 participants and coming to the App Store later this year.
There are 4 unique models in our game, each with its own twists and made in Blender. The first model that was made, called Devil, got its inspiration from Nintendo's 2012 game Face Raiders, which also served as inspiration for our game. By continuously altering a simple cylinder primitive, we eventually achieved the elegantly curved helmet. Another model that was made is called UFO. We heavily experimented with the material's texture to give it a mysterious metallic aesthetic. The Reality Kit renderer manages to represent it quite faithfully, but finding the correct parameters for exporting it presented itself as quite of a challenge. After modeling 2 hovering models, we decided to make a flying model. For that, we mapped a feather image to a plane, cut the rough shape of the feather. We did that with 2 different feather images and used particle systems, which makes them look as if they are angel wings. Thus, the model Angel was born. Furthermore, we used particle system to make a white fur to hide the bald wing spots. For the last model, called Greek, we used the angel wings and attached them to a helmet modeled after those in ancient Greece. We also used the particle system to make red tuft of hair. These models perfectly fit our hovering or flying theme, and keyframed custom animations bring them to life. Thinking we were finished with the 4 models, we started exporting them right into USDZ VR Reality Converter. Our models underwent a puny number of 120 iterations until we were content with their looks and behavior. To optimize for real-time performance, we used manually UV mapped textures to approximate the particle system's output, while using less triangles. I would like to thank Dominik Schetter for helping me with these essential steps.
To achieve convincing face replicas, we first looked at animations. Instead of relying on cartoony or manually crafted artificial movements, our own facial expressions bring life to every replit. We devised Face Record, a toolkit that employs the True Depth camera to record frame-wise coefficients for over 50 facial muscles in real time. Stored in a tabular format, the Face Battle runtime then dynamically reconstructs facial meshes on demand, adapting to the current operating system's preferred face geometry and animating at smooth 60 FPS with high level of detail, all completely transparent to the player. So replits can be happy, or sad, or cross. To personalize their looks, we prompt players to capture their face on startup. By overlaying the system geometry on their live-tracked face, converting from 3D to view space and mesh transforming the captured image, a texture is created and UV mapped onto the player's replit. Once all assets have been created, the heavy lifting commences. The players and spectators establish a local multi-peer connectivity session and sync all captured assets. Our Swift UI-based pairing interface makes finding peers a breeze. Each device then starts mapping its surroundings, collecting visual points of interest and surrounding object shapes, while continuously broadcasting compressed world data that ARKit uses to establish a shared reality. For the best result, ensure that all devices' cameras point in the same direction while orienting yourself in space. Once all maps were merged, each player establishes an origin entity that follows them. RealityKit renders their replets orbiting around this point. On tap, we apply a strong force on a new short-lived orb entity with collisions enabled. And on hit, each replit plays a unique anger animation completed with spatial audio cues. That's a lot of data, so carefully optimizing what is being synchronized was essential in making the player's experience enjoyable. We hope you enjoy our game. Thank you, and see you next time.